Good morning, everyone.
Hello. It seems we've already got a few folks here.
Morning, everyone. How y'all doing?
Good morning.
Nice and early.
Yeah, appreciate you doing that for us, Tom.
Yeah, sure. I was going to say, where are you, Drew?
Maryland.
Okay. I was going to say, is anybody here in on the Pacific Coast?
No.
7 is just too early for an engineer, I guess. Well, it's 8. Might as well get this party started. So I want to start by saying that in lieu of Daniel Wallace, Nick Hughes has asked to step up as captain. Oh, that's the right term. And we're very grateful. I had a conversation with Nick a few days ago about what this working group has been talking about and what their concerns are, and what we'd really like to see moving forward. And we talked about some of the ideas that I've got and some of the ideas that he's got around possibly what we can do. And before I dive into things, I should say, Nick, was there anything you wanted to say?
I just wanted to say thank you for the opportunity to lead this team, and definitely looking forward to collaborating with the open source community. And hopefully I don't make a huge fool of myself. Feel free to tell me when I am.
Don't worry, it's open source. They will. Okay. So if we step back, what was conveyed to me, and somebody feel free to correct me if I make any mistakes here, what was conveyed to me is that the main things that we want to see from a Salt Cloud is stabilization around what it takes, what it means to have a cloud be supported, extraction of Salt Cloud from Salt, and oh, there was another one. Sorry, what was the other one, Nick? I'm not off to a great start.
It's too early for you.
It is.
So there was a lot of talk surrounding, like the existing documentation and really the existence of tests and the current state of things. And then there was also the future facing things. How do we move forward in a smart way that you already mentioned?
Okay. So in talking with Nick, we kind of outlined that we feel like there's a couple of different options moving forward. One is that we kind of keep the status quo and we try and build what we can into Salt. Two is that we take Salt Cloud in its current incarnation and rip it out. And three is that we kind of take a fresh approach and look at the problem. Now, the upshot with number one is that that's the easiest. The downshot with number one is that's probably the least effective. The upshot with number two is that we would see some change and some motion, but it doesn't get rid of the fact that the stand-up of compute systems is really not tightly in line with how a lot of the components inside of Salt Cloud are written today, because a lot of them are modules and states, right, at this point, because that makes a lot more sense as a mechanism for managing complex clouds. When I first started writing Salt Cloud, it's worth noting that pretty much the only thing that clouds had was compute. I mean, we're going back to a time when you would set up HA proxy manually and you wouldn't be using a cloud services. Even load balancer, which was one of the first things, right, that cloud services came out with as they continue to barrage us with more and more infrastructure services. And so my argument with number two is that the fundamental approach that we have, I don't think lines up in a really optimal way to how to solve and address the problems of cloud today. And so in talking with Nick, I introduced him to something that I've been playing around with and wondered if, and wanted to run it by everybody here, wondering if this would be a viable option moving forward. Now, some of you may have heard me rant a little bit about a project called POP. Now, POP is an evolution of the Salt loader. So the Salt loader's got many merits. It's got a number of downfalls. It really was a very ambitious attempt to create a plug-in system. And it served us very well. I mean, we can make a lot of plug-in subsystems inside of Salt. Salt is very pluggable. But a few years ago, I started playing around with the idea of what would it look like if I had a standalone? What would it look like if I had a standalone plug-in system? And I started iterating on that concept. Wrote it in a couple of different languages, got some more ideas. And what came out of that was POP. And POP addresses the problems that we run into with the Salt loader, as well as abstracting solutions to a number of problems that I feel that most projects, especially open source projects, run into. And without sitting down and going over a really extensive POP overview, I feel as though that POP gives us a good platform from a plugin perspective, especially to solve a lot of those core problems that we have inside of Salt Cloud. And one of the other things that's noteworthy is the recent project that Megan's been working with me on, Heist, which is a new take on Salt SSH. That particular project is built entirely in POP. That's been going very well. And let's see, our enterprise platform is built using an earlier version of POP. We actually want to move that over to POP. So this isn't a model that is out of the blue, crazy, and project called Umber is built on POP, and I've built a number of other things. And so I feel like this is a so far fairly vetted for where we are. And so beyond that, I've got another piece that I just threw up on the SaltStack organization last night called Item. And Item is an implementation of the Salt state system inside of POP's plugin architecture so that the state system itself becomes pluggable. But it's also modernized, built on Python 3, and takes full advantage of async IO. Now, my thinking here, and what I wanted to run by everybody, is, thank you, Nick, for posting those in the chat. What I wanted to run by everybody is this idea that if we have Item, which allows us to run states asynchronously and in parallel using async IO, so it's incredibly efficient. And if we step back and we say, let's look at a cloud from the perspective, sorry, there's a lot of chatter around me. Is that bothering anybody else's audio?
It's at a minimal over here. It's not a big deal.
Okay. Okay, so my thinking is that if we use Item, we should be able to port the states that we have fairly easily over to it. As we port those states over, we can write fresh tests and fresh documentation. We can create a system that is purely run by Salt states. And again, everything becomes asynchronous. So it becomes very easy to be able to do lots of parallel executions against target systems. And then that base system that we would start to build also has a few other benefits. One of which is that POP allows us to do something called app merging. App merging means that everything doesn't need to go into one code base. It makes it very easy to create full support for a complete cloud in its own repository. That support for a cloud gets to be released in its own right within its own repository, which again makes a lot of sense. One of the main problems that we run into with Salt Cloud is that we put a bunch of stuff into Salt and then we're waiting for the entire cycle of Salt for release. Whereas we want interactions with APIs to be released relative to their compatibility with those APIs. And so again, what POP gives us is vertical app merging, which means that the plugin subsystems which are exposed inside of POP can be transparently extended by external applications. So again, that means that we would be able to have one project that's using POP and Item that has basically the spine of that system. But then we would be able to have all of the AWS support in its own repo, all the Azure support in its own repo. And then we can also test all the Azure support in and of itself. It doesn't need to be tested alongside everything else because for obvious reasons. And similarly with other projects. Now, one of the other things that I was working hard to get finalized in Item yesterday and last night is that now it also supports nested a nested plugin tree. And so salt, we've got the states directory, and that's the only place to put plugins. With item, we can have a states directory, but then have a subdirectory called AWS or a subdirectory called compute, or however we want to lay that out, okay? Which makes it a lot easier to organize where everything goes, and everything becomes much cleaner. Okay, so that's kind of an overview of a concept. Are there any initial knee-jerk reactions? Who wants to call me out as crazy? Who thinks this might be an okay idea and thinks I should keep going?
Well, it's an interesting idea, but I imagine there's going to be other circumstances by which you want to start moving states into this item-based system. So why would the sort of Salt Cloud work be differentiated fundamentally from moving other Salt states into sort of an item-backed state execution system?
Oh, that's an excellent question. And I definitely do want to move other aspects into this system. Now, when we step back and we look at this, the thing about Salt Cloud is that for the most part, it can be executed in a much more isolated manner than the rest of Salt, right? The rest of Salt comes in and the complete fabric around how Salt works with pillars and grains, etc. And it's very tight, and Salt's very tightly coupled into the remote execution system. If we step back, I'm presenting a couple concepts out of a larger kind of swath of concepts that I want to work towards. But I also don't want to present this as I want to do a Salt rewrite. I want to present this as I think it makes a lot of sense for us to pick and choose pieces of Salt which can be isolated into their own projects in a clean way, and that hopefully that isolation drives acceleration of development. As we move forward, I see this as, so Heist, for instance. Heist is a really good example of, I want to use this platform to pull Salt SSH out and say, here's a much better approach to Salt SSH. It's async, it's all new, it uses POP. Similarly, after cloud, I would really like to create, I've been working on creating a transport layer on POP. I've also got a project that gives the structure for rewriting grains on top of POP. You can see that's just called grains in the Salt stack work. There's not a whole lot there, just enough to say this is clearly a better way to generate grains than the way we're doing it now, but I must admit that's not a high bar. And so I definitely do feel that the optimal situation is that moving forward, all of these structures in Salt would be moved out. But I also think it makes sense to not try and bite off more than we can chew too terribly quickly. Does that answer your question, Adam?
Yeah, thank you.
Okay.
Hi, Tom.
Hey.
How is the transition process can look like from Salt Cloud as is to the future you described?
So I'm not proposing that Salt Cloud maintenance ceases by any stretch. My thinking here would be that we would take the next few months and we would look at what kind of traction we have and in moving some things over to this new structure. And I can begin to show you what that structure looks like on the other side of this little Q&A stop. And so then one of the challenges would be that this migration would probably mean that states probably wouldn't perfectly match. We'd want them to probably be as close as possible, don't get me wrong, so that stateful migration would be easy. But there are a few questions as to what that would look like. The other thing is that we're looking at being able to execute the runtime differently. So IDEM has a pluggable runtime system. Generally, so one of the big things about moving from Python 2 to Python 3, just as a migration reference, just to use one of the world's most painful technical migration references, is that Python 3 changed fundamentally how certain aspects of Python runtime worked. Now, they came back and therefore said, look, your code will function in a fundamentally different way. When I'm going through item, I'll show you where runtime plugins exist. One of the great things about runtime plugins is that they're just plugins. Everything's just a plugin now. And so from a migration perspective, it might work for us to create plugins in item which sufficiently emulate salt's behavior for salt states, that migration can be made even smoother than asking people to make minor changes to existing states. But the structure of a state file doesn't really change in item. Does that answer your question, or were there specifics you were looking for that I didn't get?
Mostly specifics on how to actual tools, what is the transition period, and but maybe it's too early to discuss this.
Okay.
Another question is, one of the first meetings of Cloud Working Group discussed this problem of when you transition Salt Cloud to a state system, you need to get a result from one state and seed it as input to another state. Basically, if I create a availability zone, I need to somehow consume this ID or something like that in a different state. And the solution proposed was to use slots, but there is not any clear plan on if that would be usable and how to do that exactly.
So there's a number of different approaches that we can take to this particular problem. Slots is obviously one of them. To be honest, I'm a little more inclined to look at it from a broader scope. So again, one of the nice things about item is that it's all torn up. Everything's cut apart. And so it's a lot easier for us to be able to do something like, say, maybe we can just re-render an SLS file later on, and say that information gets inside of Jinja, which would make it very, very easy. In a nutshell, I feel like I guess what I'm saying is I feel like that's a much easier problem to solve with item than it is to solve with a state system. And I also feel as though that's, when we boil it right down, I feel like that's the big challenge for the state system overall, is being able to take information from one state and apply it to another in a very transparent way. And I feel like that's, again, like one of the main things that I'd want to tackle. But at the same time, I'd like feedback on how people think that would be an optimal way to solve the optimal way to solve that. Because I feel like slots has certain advantages. But I think, I guess what I'm saying is I'd love to have an open discussion about that. And it's way more solvable in item because it's young enough that I can break crap, right? As opposed to the salt state system, where one of the big things that holds me back is every idea I have to solve this problem ends up breaking things or making the state system run so much more slowly or inefficiently that it becomes very problematic. That might not be a satisfactory answer. It's I agree with you, but I don't necessarily have a perfectly solid plan on that quite yet.
So at the risk of pulling away from these interesting technical challenges, I'll rephrase my understanding of where we're coming at from here. One of the bigger desires is to separate Salt Cloud from Salt Core. Biggest reason being we want Salt Cloud to be able to move at the speed at which it needs to move, not at the speed so much of Salt. So when, and a consequence of that separation will also be, instead of having these individual drivers built into Salt Cloud, for example, Azure, Amazon, there will just be separate projects. I mean, separate Git repos, whatever, for each specific driver. So now it just moves as fast as the latest commit for getting these changes in. So we don't have to wait months for the next version of Salt to cut. before we get the newest API updates for Azure, for example.
Exactly.
And the way that one of the ways that we can do that, and this is my ignorance, is by migrating the core of Salt Cloud over to sit on top of Salt Pop and or IDEM. And this is my ignorance. I'm not good on the difference between the two.
And this stuff's all brand new, so.
Sure.
No, I certainly can't blame you for ignorance.
I want to make one note that I put down was you mentioned that Enterprise is moving over to Salt Pop. Is that right? Did I get that right?
So the enterprise system is currently built on an earlier version of POP.
Okay.
So POP is actually the fifth version of a plugin system that I tried to put together. Enterprise is built on the fourth version.
Okay.
Which again is one of those situations where I come back and I say that I feel as though the model's been pretty hardened at this point. We've already learned a lot through a lot of software development. And then I forked that version and open sourced it.
Okay. Yeah, that makes sense. I'm kind of done talking. I'm just pointing out I'm really not up on the differences between POP and IDEM, but I just wanted to be sure we at least agreed or mostly had a consensus on the direction that we want Salt Cloud to go.
Okay, excellent.
I guess I have an even bigger question regarding Salt Cloud. What reasons do you see to work on Salt Cloud when tools like Terraform and Pulumi exist?
That's a really solid question. To be honest, it's
sorry. I mean, I have my own answer to this. I think Salt has an advantage of using Python, and Python is really easy to develop. And if some driver is missing some functionality, it's quite easy to fix or make your own plugin or driver. And this is much easier than writing cloud drivers for Terraform in Go and stuff like that. But I'm quite interested what other people think about this.
So I can cover a reason coming from my end. And the question that you presented has been debated significantly inside of SaltStack from an engineering and a management perspective. And one of the things that we're seeing right now from how do I put it? If we come back and we look at the job of, we'll say IT professionals, data center operators, whether you call them DevOps, SRE, or whatever at this point, SRE being much more popular now, but a significant portion of what we have to manage ends up being either cloud resources or SaaS resources which exist behind APIs. When we're looking at this from a cloud perspective, one of the benefits of the architecture I'm trying to put together would be that, like Salt, we'd be able to write states that interface with virtually any API. The model that we're presenting isn't particularly cloud specific. As was asked earlier, would this model be applicable to other verticals? And the answer there is definitely yes. What we're looking at is an idempotent normalization layer for interacting with all types of computational systems. In a nutshell, we could have states that manage your GitHub or GitLab accounts. We could have states that manage serverless deployments from a high-level perspective. We could have entire projects which use this foundation and all of the states that we're looking at creating from a cloud perspective to abstract a higher layer of managing things that are extremely complicated, like all of the functions that need to be loaded into a serverless array. Similarly, this system can be used to interact with internal software APIs. And so I feel as though the expansive capability of this type of platform is much better than what we see in a Terraform. But one of the other benefits is that it allows us to do things in a highly targeted way still. One of the problems that we run into with Salt is that it kind of tries to be all things to all people. And
it's a framework.
Right, it's a framework. And one of the ways I explain it from a business perspective internally is that we've made a bunch of bulldozers And if we as a business want to make more sales, then we have to make spears. That's what people buy and that's what people want. They want solutions to problems as opposed to simply frameworks. One of my goals here is that we can create high-level solutions to specific problems in a much easier way, because then it makes it a lot easier for us to say, here's a project that is doing a very specific thing, built on top of an existing platform that's very flexible. But I'm very curious to hear other people's answers to this particular question.
I'll jump in here. You know, it's a much less technical and political answer for sure. But while Terraform does have the bulk of the market share right now, it seems, especially in regard to cloud infrastructure management and things of that nature, I don't feel as though the war has entirely been won. There's a lot of people, myself included, that I think aren't quite happy with a lot of the workflows that take place inside of Terraform. And especially people that are familiar with Salt and how it operates and the promise there. That's one of the reasons that I'm really excited about this future. Is sort of having a competing product that we can view as the resistance, and build it towards some of the workflows that we're really used to and love about Salt.
I appreciate that, Nick. And my other hope is that the system would be flexible enough that those workflows have to change significantly over time. Like we were saying, the workflows around Salt Cloud, when it was originally built, were so focused on just compute because that's all there was. What are we going to be dealing with in only a few more years' time as the market continues to evolve in its rather chaotic dance? The other thing I'd like to agree with Nick on is I haven't had the luxury over the last few years of being able to just be an engineer. I've had to do management garbage. And we're in a situation with cloud automation tools where we've really had the first cloud automation tool in Terraform, which has made a significant impact on the market and gathered significant market share. There were a number of attempts to normalize cloud APIs before this. But Terraform is in what we generally call at this point the trough of disillusionment, if someone's familiar with that particular model of adoption curves. Because what happens is that it gets large, widespread adoption, but then people come in and they say, here's the limitations and the world has changed, and there's much more interest in a new approach. And again, I feel as though if we can make a sufficiently flexible approach that's more forward-thinking, then we can take advantage of current market placement and evolution. Sorry, anybody else have an answer?
My only thought is is mostly elaborating on what's already been said is, I want to avoid getting into what I call getting into a knife fight. We don't want this to be about us versus Terraform. We can't ignore the fact that we're stepping into Terraform's territory, but we want to avoid this turning into just simple feature comparisons. And I'm going to talk out the other side of my mouth now and say the goal of something like Salt Cloud is in a world that's driven by APIs. If you make a platform where you can statefully define your world that's driven by APIs, you can do way more than just atomic cloud things.
Oh, yeah.
Going back to Tom's example, deploy something serverless, manage your GitLab repos. There's entire API sets for Kubernetes clusters, and there will be use cases that we don't even know what they are yet. But if you have a platform that's meant to drive the world via APIs, it's not a challenge to continue using the same platform to manage whatever it is that's going to look like. So it's going to take a long time, but I really think that's where it's going to go. The risk that I see is the wonderful thing about Salt is all the things that it does. The horrible thing about Salt is all the things that it does. And it's very easy to become overwhelmed because you can do just about anything. So picking the right thing to do is always the challenge, finding where that highest impact is to make a big meaning to people. That's it. That's my thoughts.
Well, and one of the things that I like about your comment there, Drew, which is very wise, goes right back into driving development not only towards platforms, but platforms that drive the creation of solutions. And this is a lot of my hope. I can only call it hope at this point of this platform that I've spent the last year and a half working on in POP. I say year and a half. That's when I forked it from the old one. Blah 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 blah. That I've honestly spent the last 5 years with. Is that one of the main ways to solve the problem that you're talking about, Drew, is compartmentalization of the message and the abstraction and really the attack surface. Because when we come back and we say, I want to solve specific problems, part of the reason why POP has this app merging concept, and after I'm done yammering about this, I'll dive into kind of a demo, and I'll do a code dive to kind of show everybody how this works. But the problem that I feel like we can solve with app merging is that you can make a standalone application, a standalone repo, a standalone expression of managing GitHub, and then just run it. So that instead of looking at software like saying, Python is the thing that solves everything, I can say Python import anti-gravity. And that's kind of the similar approach that I want here, is to say that this item and POP platform gives us the fundamental linguistic tools, but that it can be expressed in a much broader sense, but still in a targeted way. Okay.
I've got some additional comments on why I think this is extremely valuable to add into the Salt Stack framework in the context of the proliferation of other tools. So what we're seeing a lot in our practice is DevOps practitioners and also DevSecOps operators. They have to generate these curated tool sets, and they have to start using a whole bunch of tools. And of course, once I started using Salt, I figured out that solves problems. It can become the primary tool. And you get to the point where, like, well, wait a minute, I could have 10 tools, or I could have 2. And you get to a point where, so I'm attracted to, and the reason for that is that you've got this consistent philosophical architecture with Salt, where you can just jump from one system to the other, from one component to the other, and it all feels self-similar. So it's like once you know it, you know it. And I'm attracted to continuing to develop the cloud functionality so that we can add in the Salt Stack philosophy, in a sense, on top of things like Azure and on top of things like AWS. So that you're interacting with RDS Aurora, for example, but it feels saltier than you would have otherwise expected. And that's going to help the community so much, because it's going to simplify and streamline a lot of workflows.
Okay. I deeply appreciate your comments. It's very encouraging that the ideas that I've got here appear to have legs. Okay, let me. I imagine there are more comments that could be made along these lines, but let me move forward and give you guys kind of a demo and overview of how this system would work. Now, I have to be very, very straightforward. I've got a lot of stuff working in the background. I don't have a whole lot of docs yet. There's a lot that isn't here. Nick did post a link to the docs for POP. The docs for POP are pretty well fleshed out. There's a number of areas where they, of course, could use some polish. But hopefully there's enough there that you can start to get a gist for what the devil's going on there. But so let me start by going over ITEM really quick. ITEM is a POP project. A POP project means that the code is structured in such a way that it can be logically 100% pluggable. I say logically because it's more like 5/9 of pluggability, because, right, there's a limit. But the only thing that doesn't really need to be pluggable is basically this this run script, which is how we create a fresh pop project. Now, as you can see in this run script, all we do is we import pop, and we create something called a hub. One of the challenges that we have with the salt loader is that we want to have like execution modules and states to be accessible everywhere, right? And we're always shoehorning them into other locations. The hub creates what you can think of as a big hierarchical self variable, where all of the information that you're dealing with can exist on a hierarchical structure, as opposed to existing on a bunch of class silos. Now, I've got a whole spiel on philosophy of how I feel like this is a evolutionary approach to object-oriented programming. It takes a lot of OOP concepts, functional concepts, etc. But the first thing you do is you make a hub, okay? Then when you make a hub, hubs come with plugin subsystems. You can think of a plugin subsystem like Dunder Salt or like Dunder States or whatever, right? When you make a plugin subsystem, in this case, we're making item, it becomes available on your hub. Your hub is now available to all of your application, which means that we no longer have to shoehorn plugin subsystems into different areas, which makes the spine of the application much, much simpler. And so in this case, we add a plugin subsystem, and this would be the logical equivalent of the salt loader is saying dunder item.init.cli, okay? And so once that's all set up, I should cover really quickly. If we take a look in this item directory, there's a scripts.py that has basically the same code in it, so it's used by setup tools to satisfy setup tools. I won't rant about why I hate setup tools right now. But when we create this new plugin subsystem that goes onto the hub, in this case item, it goes in and it looks for an init.py file. If an init.py file exists and there's a dunder init function in it, then this is the plugin subsystem's initializer. So it hopefully feels kind of familiar with normal object-oriented programming. This init.py defines the pattern that is used inside of this plugin subsystem. And for the most part, you guys aren't ever going to need to write this. For the most part, what we're going to need is just drivers, right? But the nice thing about these plugin subsystems is that, again, it allows us to abstract everything as plugins in a really clean way. And so as we start this up, you'll see that there's a lot of these references on the hub, as all of the functions that you're interfacing with now exist on this hierarchical namespace. One of the ideas here is that if we have a hierarchical namespace to store data, then we get the benefits of having global access to data without the bad sides of having globals. And it allows us to solve the self.opts problems as well. Because now we're able to put variables, in this case, in certain locations, and then that communicates who inside of the hierarchical structure should be editing that data, but everybody still gets access to read the data. Because frankly, hiding data from different parts of a single process is I would generally argue, silly, because it certainly doesn't add anything from a security perspective. Since once you're in a process, you own the entire memory space of said process. Okay. So what we do in here is we're firing up the state system. And each execution of items state system exists as an isolated name inside of item. This means that logically you could run multiple state system executions in asynchronous async IO parallel, okay? Logically. Now, we take all of the options and configurations for that specific run. We load them onto a data structure on the hub, and then we're ready to go. At that point, things are actually greatly simplified over the existing state system. We run resolve.gather. What this does is it gathers all the SLS files. And so this is our logic that deals with an SLS tree. The gathering routine is pluggable. So if you want to be able to gather SLS files, right now I've only moved over support from gathering directly from a file system. But it's pluggable, and you can think of it kind of like file system backends, okay? And so GitFS could be migrated over to this so that you could execute this anywhere that has access to Git, your Git repos, and then it will just magically work, okay? Next, we go through the compile process. And so actually, let me, all right. So this SLS directory is where we've got our ability to pull SLS files from a file system. Items resolver is where we deal with handling the tree structure and taking care of all of the internal variable references that are needed for SALT inside of SALT state system. Let's see, after that, we go to the compiler. And so if we look inside of item, another nice thing, again, that we've asked for a lot in the SALT state system is that these could be hierarchical and nested. And so you can have plugin subsystems inside of plugin subsystems, okay? And so as we look inside of here, we see that all of the steps and components of the compiler have been broken out into individual modules and individual functions. This also means that from a plugin perspective, if somebody wanted to intercept one of the stages inside of the compile, they could just insert a plugin, and then that plugin would have access to wherever the compile is at that particular phase, okay? Next, my favorite thing, which will make more sense to everybody, is, does anyone know how you get a new requisite added to SALT? So say you've got the require keyword, right? And you've got watch and prereq. So does anybody know how you get a new requisite added to SALT? You asked me to put it in. So I'm still the only person who's ever added requisites to SALT. They're extremely confusing and convoluted, but not anymore. Now, requisites are just plugins. And to create a custom requisite, so for instance, here's what the require requisite looks like. All we're saying is make sure that whatever we're requiring has returned a result of true. And here's what the watch requisite looks like. And then each of these definitions is actually another plugin system. So that if you wanted to add another key, you just add a plugin. And so changes post is just this logic right here that says, if there are changes, then we get the condition which is passed into the changes, which in this case was the condition passed into the rule set, which was mod watch. So our mod watch functions still work, and it's only a few lines of code. Okay. Next are runtimes. So if we come in and take a look at item, where did I put those? Run, that's right, okay. Runtimes become pluggable. Right now, the runtime, all of this stuff is built into the runtime of the state system. And so in item, all you have to do to have a completely new runtime is this right here. Inside of the state system, we have a multi-branching recursive algorithm that evaluates requisites and evaluates the flow of the application. Inside of item, I do it very differently. It's much more iterative. What we do is we create a sequence map of all of the states that are currently present, and then do a complete resolution of all requisites on said states. Add that to the sequence map and then determine what states are available to execute next and what states have requisites that are still required. This also makes recursive requisites a lot easier to find. And so then when we've got that map, it's very easy to say, given present requisites. These are all of the states that we can all just run at the same time via async IO. So we can just queue all of those coroutines up and run them. So the nice thing again here is you've got a complete parallel runtime. You can probably spend a few minutes and look at this code and say, I can see what it would take to make a serial runtime. Not a hard thing, right? Okay. Next is renderers and outputters. So these are still concepts that have to exist. Instead of building those directly into item, what I ran into is that renderers are really useful in a lot of places. It's really nice to be able to have the ability to render any arbitrary data file from a lot of different locations in the code. There's another project on the SaltStack.org called Rend, which is just for compartmentalizing renderers. It implements render pipes, and it also implements outputters. And so all you have to do is go back to earlier when we say hub.pop.sub.add, which adds a new render subsystem, okay? Or sorry, which adds a new plugin subsystem. And then we could add the render plugin subsystem. And then that gets installed as a separate Python project. And so it's released on its own. It's released as a Python project on PyPI, okay? And Rend is up there. You can take a look. Again, most of these are fairly bare bones. A lot of porting just needs to happen at this point. And for the most part, that porting doesn't need to be too terribly difficult. Okay. The next thing that I want to cover here is a quick look at states. So, of course, we have tests. And the tests that we have, here's a couple of simple states that we can take a look at. Nest is a good example of the fact that we can now write a state where the actual state reference itself is deeply nested. What we're looking at is, so much of this comes down to this concept of a hub. When you write a state, that state is saying, here's a reference that I want to hit that exists on this POP hub, so that you can expose whatever aspect of the hub you want into the state system. Similar to how Dunder Salt gets exposed to the state system or how states get exposed. I see Drew closing his eyes and concentrating as he's trying to keep up with my academic nonsense.
Right. If I see less, I can think more.
This is a very true statement. All right. But so in a nutshell, as you can see, if I want to call nest.again.another.test.noah, effectively on my hub, I've got nest, and then nest again, another test.py. And the function. So that logical mapping still exists. It just now exists on a hierarchical namespace, okay? So again, the goal there to illustrate that states still look the same, except we can do some cool stuff with your state deck now. All right. Oh, the last thing to cover is dynamic names. So I've talked about this app emerging thing, and this is where stuff gets kind of crazy. Since we have a hierarchical namespace, we can dynamically load separate plugin subsystems onto that namespace. Now that means that, like I was saying, there's a rend project, and instead of importing rend, we add it to the hub, okay? That's what I call horizontal application merging. But for this project, we want vertical application merging. Vertical application merging means that I can have a completely different set of code, and it adds modules to this pieces of code. This pieces of code's plugin subsystems, okay? Now that means that we would be able to say have states right here, and then have another project that defines that it dynamically adds to states, so that when item loads, pops dynamic plugin finder detects these other projects' plugins and loads them up. Okay? And so the way that we do this, and I don't think I've actually put this into item. Yeah, I don't have any Dyn names in here. The way that we do this is that a pop project has these 3 files on the top outside of the plugins. Version.py should be fairly straightforward. It has a version number in there. I mentioned scripts. Conf is where the good stuff is. What? Oh, for the love of. I'm on the wrong laptop. I put all that stuff into, I didn't git push it. Oh, this is what happens when you write code till 2 in the morning. The Heist has them. Right, Megan? Heist has some Dyns in it?
Yeah.
Thank you. You're wonderful. This is actually a really good example of just using this conf file. One of the problems that you run into when you're writing applications in general is dealing with configuration values, right? And so POP builds a standard way of importing and managing configuration values across multiple applications. The benefit of this is that every POP application can load its own configuration values and its own config files in a very, very easy way, where you've got a single source of truth, and all you have to do to add another CLI option is toss it into this dictionary. All of the functionality of argparse is supported inside of Python. The ability to load up config files is fully supported. The ability to do all the config file loading malarkey that's inside of Salt, like using all the config file loading malarkey inside of Salt, like includes and config directories, it's all in here. And all you got to do is fill out this dictionary. It's, frankly, it's one of the most liberating things I've ever built. But what I want to focus on is this Dyn value right here. What this Dyn value does is it says, these plugin subsystems that I'm creating in here are meant to extend these plugin names, so that anybody else who wants to extend Tunnel, the Tunnel plugin subsystem, or the Heist or Roster plugin subsystems that exist inside of Heist, can create their own POP project, install it, put in their config, in their conf.py, that Dyn statement. And when I load up Heist, it will automatically find and extend its own plugins. This Dyn system is what allows you to make all the stateful plugins for AWS or Azure or whatever in your own project. Make sure that you've got a Dyn declaration that should only have to say states and exec for execution modules. And if it's installed, when you run item, it'll get picked up and you're done. Okay. Dynes are, I love them. It took me a while to figure that one out. All right. The last thing I want to go over is one of the big benefits of Terraform and of Go software. When you write something in Go, you get one convenient portable binary. You don't have to install, and you may have already realized that everything that I am currently explaining suggests that you have to do dependency management like mad. We have a solution for this. Whenever you make a POP project, there's a piece of software called PopSeed that comes with POP that makes it easy to fire up a quick POP project. That POP project, when you run PopSeed, creates this build.py file. Build.py is a wrapper around PyInstaller that creates a single portable binary of your application with all dependencies built in. So now, when you have